welcome to today's colloquium, the last in this semester, on a particularly hot and sweaty day. Today's talk will be by Brett Buttliere. Brett hails from a place close to Chicago, I guess. He started studying at Radley University, and then he went to the Netherlands and received his master's degree at Tilburg University. And he joined IWM at the beginning of last year, and in addition to his PhD project, he is involved there in, and he's very productive in a science campus project. And his background that he did, the stuff that he did in the Netherlands, had a lot to do about, the group there is investigating the role of science, how to improve science, in the science campus project. And the idea is to investigate the role of conflict in social media. And from these two backgrounds, it was just natural that for his PhD, which he's going to present today, he tries to combine these two ideas. So today we're going to hear and listen about the role of science, conflict in science. Okay.
Yeah, thank you everybody for coming, and I hope it will be worth your time. The title of the talk will be The Role of Cognitive Conflict in What Scientists Talk About and Work On. And these are some of the people, as you said, Bradley and then Tilburg and here. So just some background ideas. You're going to already went over many of them, but I like the idea of cognitive conflict. It's somehow a organizing concept for me from Messenger. You will see this later. And then Metascience. So the idea is to make science more efficient. And the question is, does conflict drive science? And as you will see as I go through the talk, the theory at least suggests yes, and I think that I have some data to suggest that as well. And this data will be organized around three general questions, which you can see right here. Can you still hear me if I'm away from the microphone? I think so, okay. The first one will be, are scientific comments that are longer more negative? So somehow in our science campus project, we look at the motivation and how people respond when they disagree. And so we will take this into, okay, anyways, we'll see this later. Then the second one will be, do papers with more negative abstracts get more attention? So the idea is, again, this cognitive conflict in science, and how does the outcomes of the paper relate to the conflict that this paper brings up? Yeah? And then finally, the final question will be, are larger fields about larger problems? Okay, so, or things that are more disagreed upon. For instance, like evolution or heliocentrism or Einstein, this sort of stuff. Or disease or disorders, as we will see later. And then the general goals of the talk will be to tell you about my work, and then in some sense, hopefully create some conflict so that there is some discussion, and then elicit feedback about different things. Okay, so enough of the beginning. Yeah, suggestions. I will outline some problems, and that's what the paper is for, and I would like to make your suggestions on there. The questions I will highlight will be on the paper. And it won't be like a voting thing where I'll do the one but I will take it into account. The slides are somehow like a backup. But yeah, anyways. Okay, so everybody when I talk about this, ask me what is cognitive conflict. Because, I don't know, it's unclear. But I will say, and the Messenger, for instance, would say something like, cognitive conflict is when the world tells you that maybe the belief systems that you use are incorrect, right? So that's what basically it says up here. And this is threatening because we use these beliefs to get to our goals. So as things that are alive, we have goals, like to stay alive. I left that on. Anyways, stay alive, get food, things like that. And when the world says that maybe the things that we're using to get to our goals are incorrect, then that is a problem, because it suggests that maybe we're not getting to our goals. Anyways, and this experience that, our knowledge might be incomplete or incorrect is really important, and a lot of very important thinkers, like Piaget or Kuhn, The Structure of Scientific Revolutions, or Popper, Falsificationism, Messenger, a bunch of other people about learning, knowledge, really everything. Persuasion, for instance, you have to first make the person feel like they have something to learn, or before you can persuade them. But And the idea is that, as Piaget and these guys said, if you think you know everything, if you feel like you know everything, then you don't learn anything because there's nothing to learn. So anyways, there is also conceptual clarity. So this is somehow a model of how it all works. And this is the outside of the person, and this is the inside of the person. And we have these beliefs inside of us, and we have information coming in that is from outside of us. And when these are in conflict, when they don't really match up, this creates some sort of cognitive conflict, which indicates, again, like I said, to the person is motivated to reduce this conflict, which then leads to productivity. So there's been a lot of work. There's been a lot of work about this actually, like on the internet or Fessinger, for instance. This is how he put it in 1950. The pressure on members to communicate to others in the group concerning item X increases monotonically with the increase in the perceived discrepancy in opinion concerning item X. So that means the more we disagree about something, the more likely we are to talk about it, basically. Or the more we perceive that we disagree about something, the more likely we are to talk about it. And then we will operationalize the conflict in different ways in the science campus and the PhD, and we will also take different methodological approaches in the science campus and the PhD, where in the science campus project, we will do it very traditionally psychologically, very experimentally. I mean, I think it's a good thing, and it is. So we measure the person and the post, and we look at the differences in the opinion to approximate the conflict, and then we predict outcomes on that. Whereas in the PhD, we will basically stay outside of the person because we will look at actual science output and try to estimate the conflict from like residual things that conflict might create, like negativity or long responses, which have already been related to conflict. So the general idea, this is a pretty old result now. I mean, this is like one of the first, but the person is more likely to respond if they disagree more with the post. So we have a post attitude, and then we have a person attitude, and the farther they are apart, basically, the more likely the person is to respond. That's the probability. So it's somehow like a replication of Fessinger. Online, this is in forums. And then more generally, we, like I said, measure the person in the post, and then we predict this. We estimate this based on the difference. And we look at different outcomes, like which ones people want to read versus which ones people want to write to, which ones they're likely to respond to, how long are those responses, these sorts of things. And oftentimes also we look at the motivation. So we ask them, instead of actually having them respond, we ask them, because it gives us much better data, how likely would you be to respond to this? Or how much would you want to respond to this? The length of responses, so that's the probability of responding. And then when they actually respond, the length of responses is longer, the more conflict there is. So just more evidence. This is also things, too much time on this, I think. We've also done a bunch of other things, like Jürgen said. So we're getting PhD, but please keep that evidence in mind, right? So we found evidence that people are more likely to respond when they disagree. We found evidence that people are more likely to write longer responses when they disagree, and that will come into play later. And now my PhD, like Jürgen said, is about conflict and productivity within science. So what do scientists talk about? Is it also things that they disagree about, with the goal of maybe making science more efficient and cooler, and stuff like that. And I would say there's very good evidence for this, for instance, in the types of problems that scientists try to solve. Generally, scientists don't solve things that everybody agrees about. Nobody's doing research that the Earth goes around the sun, for instance. There's also evidence, for instance, how people react to new big ideas. So one of these next slides I will show you is a survey of Nobel Prize winners about their experiences when they first put out their ideas, and they were quite negative. And then the review process. So when you have a good review, it's pretty short generally, and when you have a bad review, it's like you have a lot to talk about. So what type of science is best? I mean, I think I explained why we should look at science. But what type of science is best, and this is the question, and philosophers of science have really looked at this. Like, for instance, Kuhn wrote about the structure of scientific revolutions, and he basically said that extraordinary science, which is not the ordinary science, happens when the scientists disagree about something. So that's, yeah, when they really start to argue, then they start to, yeah, it spurs work in the field and they answer the question. Falsificationism, for instance, Popper was very, obviously a pretty famous guy. He said we should basically try to prove each other wrong. And then obviously Platt is the idea of strong inference, where you should take, like, this group says this and this group says this, and we're going to put them into an experiment together, and only one group can be right at the end. And that's like the best type of science. And so, yeah, also there's other stuff. For instance, Radici, whose work is pretty similar to, I would say, to ours, he did a study on papers that had been commented on and papers that had not been commented on, and showed basically that papers that had been commented on were much more likely to be in the top 5% of the citations in the journal. And anyways, we want to get to, there are lots of historical examples. Yeah, I mean, I think there's a lot of evidence for this. Also, the learning test. How many of you know the Watson 246 task? Like everybody in my lab? Okay, so, but let's just try it. So there's a relationship between these three numbers, right? It's a science question. So there's a relationship, and we're going to try to figure it out. And the way we're going to try to figure it out is you will suggest sequences of numbers, 3 sequences of numbers, and then they will see, I will tell you yes or no, they fit the rule. Okay, so it's basically, it's a pretty famous test somehow. But the numbers are 2, 4, and 8. Okay, so, I don't know, should we just skip this? But the idea is that when people do this, they don't guess for ones that will falsify the rule. They only test ones that will, verify the rule, find it true. So 2, 4, 6, for instance, then people go 8, 10, 12, and then they say yes. And the rule is actually that it's any ascending number. But people, they do all these crazy guesses, and they guess like 10 times, and you can really watch it online. It's pretty interesting. But they look for examples that confirm rather than disconfirm things. So, like, they avoid conflict. But anyways, so the way that the PhD will go is we have these different levels of conflict. This first level is things like comments on papers. So I will have, somehow there will be 3 projects that I will present, kind of briefly. And they will be at these 3 different levels. And so the first one will be about comments on papers, comments on papers that are longer, more negative, for instance. And then we could do this also with tweets, like do tweets that are more negative, get more responses, all this sort of stuff. That's one general level that we could work at. Or we could look at the papers. So do papers, for instance, that have more negativity in them get more tweets? Or do they get more comments? Or do they get viewed more? Or all? That's another level that we could look at. And finally, we could look at the problems that people try to solve. And for instance, do people who write about evolution get more citations? Or do papers that are about evolution get more citations? Or do they contain more arguments in them? Or things like that. And so these are 3 different levels. I just somehow explained the 3 projects, but yeah. So that's what those will be the 3 projects generally. So the first one will be it will be a replication generally of Radici, and people that have shown, for instance, Schimmel in the BBC forums, that the longest threads are the most negative, and the longest comments are the most negative, and the most active people are the most negative. And so we can show that within science, and that's on the BBC forums. And then we will look, for instance, at the paper, and then also at the fields somehow, briefly at the end. The whole idea is somehow outlined in this paper, and you can find it up there. A lot of the things will have those where you can go and find out more about it. Okay, so we're going to be outside of the person, just to be sure. We're going to be testing Fessinger's hypothesis at the bottom, and it's going to be somehow a behavioral approach. We're not going into the person's brain here, so we're not measuring motivation. We're just sort of looking outside at the things. So the first will be, this is basically the data that I have or could have. The PLUS API, it's really, really good. The sample that I have is all papers that PLUS published in 2014. That's 32,000 papers. And you have all of this data, and all of these can be broken down into many things. So for instance, Twitter, you don't just get like the number of tweets, you can get like for each tweet, who did it, how many followers they have, the whole tweet, how many likes, how many reshares, the reply, like you can get a lot of stuff for each one of these. And so what we're going to look at first, very simply, because I just want to jump in, this was like my first 6 months here, was this. We looked at the plus comments. So those papers that got comments on them on the plus page. Okay, and of those there are 1,600 comments on these 32,000 papers. And what we're going to do with them basically is, we're going to look at the sentiment of them. Okay, so we're going to look at the words that they use. Right, the idea is that conflict changes the words that people will use. For instance, if I want to say that is not correct, it will include the word not, or that is wrong, or but did you think about this, or these sorts, or also another like conflict, for instance, is disease, or these are the different levels that we will talk about, right? And so the idea is that are longer comments more negative, and we're going to somehow use this bag of words approach, which is a very old approach. The Hugh and Louis dictionaries will be what we use, but basically it takes a comment and it splits it, every single word, and then it compares every single word to these dictionaries. And then it just puts a 1 or a 0 if it's in there, so you have a dictionary for negative words and you have a dictionary for positive words, and then it just compares them, and then it sums them. And the thing about this is I'm somehow trying to push the theory, so I'm not really trying to make a new method. And the Facebook paper, for instance, that was very big, used Luke from 2007. So this is a better system than that. But that obviously, just the idea is not to invent new theory. And just so it's simple. It removes the punctuation and capitalization. We could get much better. The first question that I want to ask, it should be one of the first questions up there, is how do we operationalize the conflict? So I've given you the general idea now that I would like to do. This is the way that we have gone that I would suggest is best, or that has good reasons for it. Again, this is all free. I mean, I haven't spent $1 single on any of this, and I think that's really great. I didn't say that earlier, but I do think that's awesome. So how do you think we can best operationalize the conflict? That's the question. So the dictionary, this is the last 60 words. You can see the words up there that would obviously, if I disagree, I'm worried that, or this is white lies, or anyways. One potential problem. This is why somehow I'm asking you about this. Most of these dictionaries most of the dictionaries have more negative words than positive words, like sometimes even a lot more. And so that somehow has implications for whether longer comments are more negative, because if it just has more words, maybe it will just find more negative words, right? But I would suggest, we will see later, but I would suggest actually that this is somehow evidence that we put more attention, we learn more about negativity than positivity, for instance. Okay, so these are comments. These are like one-sentence comments. So I would say almost none of them are positive at all. I mean, like really, there's not one. This one says this is a very interesting study, but it would not give us the answers we need. So even when it's like somehow positive, it's not really. Even for instance, when it's like correct, like this one might be put as positive, right? It says correct, but it says the correct spelling is, so it's like a mistake. But okay, yeah. So the sentiment of the comments. They're generally neutral, pretty neutral, but there are some very extreme negative ones, and this is the mean of the comments is right here. So I should have done it here, but the standard error is like super small, and so it's a highly, highly significant effect. And this is the sentiment of the comment and the length of the comment. Some of these comments are like 3,000 words, so they're like really long. but it's minus 0.5, basically, 0.51. And the, yeah, it's a T of 23, minus 23. So, I mean, it's a significant. But actually, this is somehow not normal. Right? It doesn't look good. So what I did was I normalized it. So this is the histogram of the count, and then this is after you log them. It's actually a really cool thing. I don't know if you know it, but yeah. And the average word count is 137, so pretty long. And then yeah, when you normalize it, it's again 0.5, and this is how it looks. I mean, it's. I just had a really good suggestion to bin them and then test if they're different from 0 each, because they get kind of sparse at the top. But yeah. But this graph, one thing I want to say is this graph is exactly the same data as that one that I showed you. But and the relationship is basically the same, except I just normalized them. So if you know, it can really make your data look better if you put them normal, because this is how they actually should be if you put them into a regression or anything like this. Okay, so we have some evidence that longer comments are more negative, right? We saw this is, I mean, it's missing this top part, basically. And so the longer they get, the more negative they become. And that's, yeah, that's that. I think this would be like the first paper, unless anything is really wrong with it. Any questions or comments right now? No, that's okay. Yeah. All right, and then, so the second would be something like moving on to the papers. Okay, so now we were comments on papers, and now we're going to go to the papers. And yeah, so we're going to try to predict the outcomes of the papers based upon the sentiment in the abstract. Okay, so if the abstract contains more negativity or more conflict, again, it could be about the keywords, then does it have better outcomes? So there are 1,200 papers that have unique comments, so 400 papers have more than one comment, okay? And this is, okay, I think I should probably just, well, I think we have time actually. Okay, so, yeah, so this is the sentiment of the comment and the number of comments. So the more comments the paper has in it, the more the negative the sentiment is of those comments. And yeah, so more comments are related to more negativity, basically. So we somehow replicate, and we can also do this at the paper level, but somehow this is like a statistical problem. Because you see, so now what we've done is taken the average sentiment of the comments, and I'm just doing this just to show you the wrong way to do it. But you can see that as they get more comments, they go to the middle, and it's like a regression to the mean. So one very negative comment or two very negative comments will pull a paper. So it's a smaller relationship, basically. But yeah, yeah. So this is Schmiel paper that we did that at the BBC, and we've somehow replicated it. And yeah. Then here is the Federici paper. So he showed that in science there is no bad publicity, where papers that have comments on them get more impact. And this is the relationship between the number of comments and page views. But yeah, so that's like a positive. More if there's more comments on a paper, then there are more page views, basically. And this is a correlation of 0.4 essentially, and which is again big effect. Okay, now we're going to the paper level. So, yeah. Okay, and this is somehow the idea. So what were the most discussed papers of 2014? It was the emotion manipulation study that Facebook did, which was pretty controversial. And then the second most talked about was female fish who like fish who look like them, basically. So white fish like white fish, and yeah, black fish like black fish, and stuff like that. But anyway, so those are like the anecdotal examples. And now let's go to the plus stuff. So this is the title of the paper. Again, you can see okay, so the mean is minus 0.3, which is not that different from 0. So you see most of them are neutral. And the standard error though is 0.15. So it's like still a huge effect. It's very different from 0, given the sample size. Abstracts are even more negative, and yeah, again, they're still pretty neutral, I guess, except. Okay, again, so now we want to compare these scores, right? We want to compare these scores to the outcomes that the paper has. And then we have all of these outcomes, and the question is which ones are important. So for instance, we have views and saves and how it was discussed, or when it was discussed, how much it was discussed, how many times it was recommended, and then the citations. And so what we did was compare them and just basically do a factor analysis. And this is, and the idea here is somehow, right now we always look at quality or impact, right? So when we talk about how good our work is, we try to say like, it's highly cited, or it's highly cited, or it's published in a high place, but we don't know what that actually stands for. And people assume, it seems like people, when they talk about how good their work is, they want to say something like quality, or had impact, or something like that. But we don't know. And so what I did basically, or what we did was take all of the scores basically and just put them into a factor analysis and see if they indicated one thing or more things than that, what those things indicated, all that sort of stuff. And this was, again, a lot of them are very skewed. So for instance, here's the full view count. I don't know that we have time for super details. You can go to the paper, it was right there. But this was the amount of times the paper reviewed in the month, October of last year. The month the last month, full month. Okay, so, but it's very skewed, you can see. And then when we normalize them, they get much better. You can see again. Okay, and then when we put them into and we look how many factors does this data indicate, the statistics say 2 or 3. And so that's at least saying that we're not just measuring quality, or we're not just measuring impact. There's at least 2 things. And yeah. And we picked 3 because the fit statistics were actually better, but we can talk about it. But the first one we termed academic impact, so this is like all the citation metrics. So you could also ask, for instance, is this just all because they're citation metrics? For instance, you also have like view counts, Mendeley saves, the number of Twitter interactions, different types of views, Facebook, the number of plus comments. You see all these different things. But if there's 4 of one metric, for instance, on the citations, then maybe they all indicate the same thing because they're all trying to measure the same thing. But they're not actually correlated perfect. Anyways, too much detail for right now. The second one is general. The general attention, that's just the total view count, how much has been talked about on Twitter, Mendeley saves, and yeah, just different types of view counts. And then the third one is like media attention, and that's like how many blog posts have been written about it, how many times it's been in Nature, anytime a website links to it, basically. And then we can look at the correlation between these factors, and you can see that somehow the general factor is in the middle, so it's correlated 0.5 with academic and 0.5 with media, but those 2 are not correlated very well. So I would say it's like general intelligence in my opinion, like we're just measuring like one general thing probably. But actually, again, this non-correlation between academic attention and media attention suggests that there's at least 2 things. And if you look at the papers that score highly on those, they're sometimes different papers. We're explaining about 33% of the variance in these metrics, so that's worse than intelligence, but better than personality, for instance. So just in terms of the amount of variance per metric that we're explaining. Okay, so we have these 3 general types of attention. And now we want to predict these with the score of the abstract, right? So we want to predict the score on these factors given, the negativity and the abstract. We would predict basically that negativity is good for all 3 outcomes. negativity being the indicator of conflict. Probably it's not perfect, but it, for this moment, I think is a good indicator. So if you look at the overall sentiment score, they're all slightly negative, but they're all not significant. So that's the first thing. So that's, I don't know, somehow surprising, somehow not, maybe, because abstract should not be negative, it should be neutral. And there's a very good distribution generally. But so then we got to thinking, and it somehow just summing. So what it does is it counts the number of positive words in